Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will help demonstrate how to check your WaveTester Optical Power Meter for proper operation using a dual OWL multimode light source.
Test equipment and patch cables should always be checked at the beginning of a testing day to make sure that they're working correctly, making sure the patch cables are okay. This will ensure accurate and reliable test results. Now, in this procedure, we will be using the WaveTester Optical Power Meter and the dual OWL multimode light source. Now, you'll see that there are three patch cables here. There's two here, one here, and then we have also a mating sleeve that we'll be using in this procedure. Now, because this is multimode, we have two of our reference cables wrapped around the mandrel per testing standards. Now, there's two cables because there are two wavelengths that we could be testing at. Now, if we're testing at one wavelength, we would only need one mandrel wrapped cable. Now, the straight cable will be used to connect the WaveTester into the link under test. And the mating sleeve will be used to connect the reference cables and the straight cable together while we're checking the equipment and patch cables. So now, we need to make sure also that the test cables and mating sleeves are the correct connector style. One end must match the test equipment ports, as you can see, SC here, and the other end must also be able to connect into the link under test. For this demonstration, we're going to assume that everything is SC throughout the link. Okay, now, the first thing we need to do is power on the test equipment. So, with the WaveTester, press the on button, and then dual also press the on button. You'll see that with the dual OWL, the 850 nanometer port is lit by default. Okay, on the WaveTester, you'll see that when it boots up, it'll say the word low. And then what this means is that there's no measurable amount of light coming into the photodetector. You'll see that there's a detector here, but it's covered with a dust cap. So that's why the meter says low. If we remove the dust cap, we'll see that we actually get a reading on the screen. Now, what this reading is showing us is just ambient room light. This is what power meters do. They measure the amount of light coming into the detector. So what it's doing now is just measuring the light from the fluorescent lights in this room. Now, the next thing we need to do is connect the reference cables to the dual OWL and the WaveTester. So we'll connect one of these to each port. So one for the 850 and one for the 1300. Okay, now what we need to do is we need to check the 850 nanometer cable. So what we'll do, we'll plug in one of the reference cables here into the detector port, and notice it says low. What this means is we probably have the incorrect cable plugged in from the duplex cable, so we need to actually put the other one in. Okay, now we get a test reading. Our target value for the dual OWL and WaveTester is around -20 dBm. See, if you see here it says -20, and then over on the right here it says dBm. Okay, so this is a good patch cable. Now what we need to do is double check the 1300 reference cable. We will put the dust caps back on. It's always a good idea to do so. We'll plug in the 1300 nanometer cable. Notice it goes back to low. This is because we haven't changed the wavelength on the dual OWL yet, but we can press the wavelength button to do so. You'll see that the 1300 nanometer indicator LED will be lit, and we'll notice that we have a reading on the screen, but it's not right because we haven't changed the WaveTester wavelength yet. So to do that, we just press the lambda button until we see 1300 nanometers. Okay, now notice that it says about it's just barely under -20 dBm. This is actually a very good reading. So what we know now is that the two reference cables that are mandrel wrapped are okay to use. But now what about the straight cable? This is easily done. What we can do is temporarily zero out the 1300 nanometer reference cable by pressing and holding the 0 button here. And what will happen is the meter will zero out at 1300 nanometers. It'll change to dB and it'll say 0. What this means is that we're reading at our reference level. So to connect the straight cable in. Now we disconnect the 1300 cable from the detector, plug the mating sleeve onto the end of the reference cable, plug one end of the straight cable into the mating sleeve, and finally plug the other end of the straight cable into the detector port on the WaveTester. Now you'll see we have a reading of 0.0 dB. What this means is that the patch cable and the adapter are introducing 0 dB of loss into the link under test. So this is actually very good. You can't get it any more perfect than this. So what we've done is we've demonstrated that all of our equipment and patch cables are okay to use, and now we can proceed with our testing.
If the power level falls below the acceptable power level range, debris such as dust, dirt, or finger oil may have collected on the connector end face or in the equipment's optical ports. Thoroughly clean and inspect all connector end faces and equipment's optical ports according to industry standard cleaning procedures. Several cleaning cycles may be required. Keeping connectors and optical ports clean at all times helps to keep test equipment in good working order and proper calibration, ensuring accurate and reliable test results. When not in use, dust caps should be kept on fiber connectors and optical ports to keep debris from collecting on the surfaces of the connectors and ports. During testing, it is highly recommended to clean and inspect both connectors and optical ports every time a connection is made. Failure to properly maintain your test equipment could needlessly result in costly repairs. For example, over time, repeated connector insertions into a dirty optical port could grind the debris into the optics in an equipment port. This type of damage is permanent and cannot be repaired in the field. If the problem still exists after thorough cleaning and inspection, the patch cable may need to be replaced. Patch cables are typically rated for a few hundred connector insertions, but can prematurely wear out or become damaged if they are not properly handled and maintained. If the power level is still too low, even after patch cable replacement, contact OWL Technical Support for assistance. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.